Okay, I spent a while going through doing problems on that multiply and divide thing, and I never got to the point where they had fractions on the other side. So I'm just going to make a few up and hope that you got the general idea yesterday, and then I'm going to move on to the next topic. So move a ring here that's in the way. Okay. Let's say that you had something like, let's move. X minus 1 over x squared plus 3x plus 2 divided by x squared minus 1 over x squared plus 5x, that was weird, plus 6. Okay, so the first thing is we need to factor anything we can. In this case, we can try to factor this one, and this one. I maybe shouldn't have jumped straight into this, but that's okay. This one you can recognize as the difference of squares. Hopefully we did that enough just recently, so you will recognize that one. This one, we only have 2, and it's got to be the same, either positive or negative, and because of this it's got to be positive. We don't actually have very many options, right? So we have 1, 2. Thankfully that does add to 3, so this is x plus 1, x plus 2, and then this one, 6, both the same, both positive. So this one, okay, so what I have here is x minus 1 over x plus 1 times x plus 2. And we could put this in parentheses so we understand it's part of kind of a product. It's really times 1, but divided by x minus 1 times x plus 1 over x plus 2 times x plus 3. Okay, now right here, you might want to go canceling this x plus 1 over x plus 1, but you can't because this is not times yet. You can't cancel junk until it's times, because when it's divided, it gets flipped. This x plus 1 is actually going to end up on the bottom with that guy. So we can't delete it. We actually have 2 of them, not none of them. So first step, invert x minus 1 over x plus 1, x plus 2 times x plus 2, x plus 3, x minus 1, x plus 1. Now I can go ahead and start canceling actually, because we know there's a times, and since I've put parentheses on everything, if I want I can just like make that longer now, because that's what happens when you multiply across. So now I can cancel these two as long as x isn't 1, and I can cancel these two as long as x isn't negative 2, and I still have these left, but really x still can't be negative 1 because I can't divide by 0. So this is x plus 3, x plus 1 squared. And pretty soon we're going to talk about asymptotes, which I think you've already talked about last year anyway, but we're going to want this in factored form in the bottom. There are lots of reasons to know when a thing is 0 and undefined. It's actually a fairly rare occasion when you want to know what it looks like all multiplied out. So this is the best form to leave it in. Okay, so let me, I guess I didn't explicitly show you how to multiply. So let's say that we had x squared plus 3x minus 4 over x squared minus 9 times okay, so let's say we have this, so that we need to factor all four things, but it's times. So right now I wouldn't want to multiply across because that would look crazy and I take forever multiplying it out, but once we get it factored, we can just write blah times blah times blah times blah and so forth. So for this one, negative 4, so they're going to be opposite. So we have, I guess that wasn't a big enough t, negative 4. Negative 1, positive 4, 1, negative 4, 2, negative 2. So negative 1, 4 makes 3, 1, negative 4 makes negative 3, and 2, negative 2 makes 0. So we want negative 1, 4. So x minus 1, x plus 4 is in the top. This one's difference of squares. And remember, with a times, if I want, once it's all factored, I can just kind of extend this line. This one's got 3. It's positive, so they match. That's negative, so it would have to be this if it's going to be anything, and that does work. And then here we've got 4. They match. They're both positive. I'm going to have to delete a little bit here because I had my personal email address pop up on the right side there. So I'm going back. What I had done here was factoring the 4. It both had to be positive because they have to match because of this plus and they're plus because of that plus. So 1, 5, 2, 2. So 5, 4. We want the 5. So we want this one. Because everything factored and because everything's in parentheses now, I can just forget the dot and go like that. Now I can cancel stuff that matches. So x plus 4, as long as x isn't negative 4. X minus 3, as long as x isn't 3. And so I have left on the top x minus 1 squared over x plus 3, x plus 1. And I'm pretty sure with the iExcel that they want you to multiply stuff out and just put in polynomials. But in your life, when you're solving problems, you will not want to do that. You'll want this like this, almost certainly. Okay, so let's do one more division. Oh. Well, I guess I could have left that. That's okay. I'll introduce a new topic. Not new, but okay. Okay, hopefully this works out. I think I just lost track of my brain in the middle of trying to build those. Okay, so here we have 12, and it's going to be matching because of that plus, so it's going to be negative because of that one. So negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. They add up to negative 13, negative 8, negative 7. So we want this last one, so x minus 3, x minus 4 over. This one is the difference of squares. Okay, and over here we have negative 6, so they're going to be opposite each other. So negative 1, positive 6, 1, negative 6, negative 2, positive 3, 2, negative 3. And we want the negative 1, so x plus 2, x minus 3. And then here we had negative 12. It's going to be a long list. Let me come over here. So they need to be opposite. So minus 1, positive 12, 1, negative 12. 2, negative 6, negative 2, 6. 3, negative 4, negative 3, 4. Okay, and we want the negative 1. Okay, now let me talk to you about the reason I almost changed that 16. We already have something to cancel here because this was already not simplified, but that does happen. So we might as well simplify this one before we write the next step. It won't hurt us. I actually wanted this to be a plus x. I'm going to just make this a plus and hope it doesn't mess anyone up. And so this one is minus and this one is plus because that puts us on this circle here. But then that cancels out this as well, so maybe I didn't mean that. I don't know, whatever. So now those two are gone, and these two are gone. And we would note that x is not 4 and x is not 3. So then we're left with x minus 3 on top, x plus 4 on bottom, and the divided by we're going to now invert. So this x plus 4 goes to the top, and this x plus 2 goes to the bottom. So now these will cancel, and we'll have x minus 3 over x plus 2. Okay. So now if I go back here, we're on solve rational equations. Generally speaking, the easiest way to solve a rational equation is to just multiply through by the greatest common denominator, or least common denominator. The greatest common one does not exist. I'm going to go off to infinity. But the least common denominator, if you multiply through it, by it, it clears the fractions so that you don't have the fractions anymore, and then you're back to kind of normal whatever. So j minus 1 over 4, j over 6. J minus 1 over 4 equals j over 6. So between 6 and 4, I could go over here and say this is 2 times 3. This is 2 times 2. So I have 2 squared as the biggest power of 2, and 3 is the biggest power of 3. So that's 12. So I'll multiply through by 12. Twelve over 4 is 3. 12 over 6 is 2. So I'm just clearing out, in this case it's just numbers, so we're just clearing it out that way. So 3j minus 3, that's distributing, Subtract 2j. Add 3. It's interesting. I guess they're just giving us 2 boxes because sometimes we'll end up with something squared. Okay, now on this one, you could do the common denominator of h squared minus 8h by just multiplying those two. The other thing you can do, though, if you have two fractions that are equal, you can flip them both upside down. And this would be nicer in this case because we have kind of like a mess of a denominator if we leave it as it is, but we have a kind of simple denominator otherwise. Negative 10. I think this was it. So this means that h minus 8 over negative 10 is h over 6. If you think about it, if two fractions are equal, then basically they reduce to the same thing. And like 2/3 is equal to 2/3, and 3 over 2 is equal to 3 over 2. So if you have 4 over 6 equal to 2/3, which it is, 6 over 4 also reduces to 3/2 because we're always just, essentially we're dividing out the same thing on top and bottom. So you can do that no matter which direction it is. Okay, so now we need a common denominator for 10 and 6. So the most 2's we ever have is just 1. The most 5's we have is 1. The most 3's we have is 1. So 30. (30 over negative 10 is negative 3. 30 over 6 is 5. Add 3h. I would do the same thing on this one. A common denominator for this one is going to be just 7 because the common denominator between 1 and anything is the anything. 7 divided by negative 1 is negative 7. Okay, so adding 7c, subtracting 9. Oh, can we ever get out of linear stuff? G plus 7G. And I think these were both negative. When they're both negative, you can also just multiply through by -1 and make them both positive. Because 2 goes into 10, the least common denominator is 10. 10 over 2 is 5. 10 over 10 is 1. Subtracting G. And then subtracting 35. Okay, I'm going to pause this for a second and go through until I get one that's more interesting, or else we'll have to make them up again. Okie doke, that took a while. So here I finally have one. Okay, so this one, the common denominator, if this were a quadratic, we'd factor it, and if this were a quadratic, we'd factor it. There's nothing to factor. This is a line. This is a line. So because they have nothing in common, it's sort of like if it was 2 and 5. We'd have to have the highest power of 2 is 2, the highest power of 5 is 5. So in this case, we have to multiply these two together because we need one of these and one of these. So we're going to multiply j plus 7 times j plus 6 Okay, so when we take this and divide by j plus 7, we're left with j plus 6. When we have this divided by this, we're left with j plus 7. And a FOIL, so minus 8j plus 6j. Minus 6j plus 7j. Okay, now, if I subtract j squared from both sides, it just disappears, because I have 1 on either side. Okay, then if I add 2j, add 42, and j should be -2. Oh, now we're back to this. Let me see. I don't know why I'm using j. Let's form fast. And this is probably going to end up something crazy unless, well, let me think about it. Okay, I think this works out now. So anyway, so in these, we need to find the common denominator, so we need to factor both of these things. So here, again, is hopefully recognizable. This one, 2, doesn't factor very many ways, as we mentioned before. So that's positive, which means they match. That's negative, which means they're both negative. That does add up to -3. So this is x minus 2, x minus 1. Okay, so we have x minus 2 appearing at most once. We have x minus 1 appearing at most once. We have x plus 2 appearing at most once, and that's it. That's the only factors we've got. Okay, so when I multiply these 3 and I divide by these 2, the one I'm left with is this one, x plus 2. And when I take these 3 and divide by these 2, I'm left with this one. Okay, so I FOIL. Minus 8x plus 4x plus 2x minus x, subtracting x squared and subtracting x, I guess, and adding 2. So negative 14, they're going to not match. So it's negative 1 and 14, or 1 and negative 14. Negative 2 and 7, 2 and negative 7. So 13 minus 13, 5, negative 5. And frankly, I'm relieved now because I got myself a little tangled when trying to make this problem up. So x plus 2, x minus 7 equals 0, so x is minus 2, or x is 7. But the thing that you need to check whenever you've multiplied things together and come up with squares, you always have to make sure that you can actually use them to solve the problem. If I put negative 2 back into these problems, I have a problem here and I have a problem here. In both cases, I get a number over 0, so you could argue it's, equal, but because they're not numbers, you can't say that they're equal. So this one actually doesn't work because it makes the denominator 0. So there's only one solution, and the solution is 7. So I've gone from fairly simple to fairly complicated, and I think I'm going to wait to do more videos until later when I've had more coffee. And so this will wrap up the video from last night. And then tonight I'll work on the rational functions part.